Right, good afternoon. Okay, in our chemistry today we'll be looking at chemical equilibrium. Very importantly, you can observe in a playground. Have you observed in a playground before where you find two children that may be sitting at the opposite end of a seesaw? A seesaw is a structure, like a wooden structure that has a balance point. If you observe that, you find out that there is a point where you adjust both kids, that you have equilibrium, that is, there is no movement in that seesaw. That kind of equilibrium system is what we refer to as static equilibrium, meaning there is no movement involved in that reaction, in that system, and it's a physical system. But what we are treating today is a chemical system, and first I want us to look at a few concepts. First we'll look at the idea of equilibrium, the properties of the system that is involved in equilibrium. We'll go further to look at Le Chatelier's principle and the equilibrium constant, and we'll talk about how temperature, pressure, catalyst, the nature of the reactants, how they affect the equilibrium of the chemical system. We'll also talk about certain processes like the acid-base equilibrium today. So first of all, the idea of equilibrium. An equilibrium system is one in which no observable change is seen in the properties of the system. So the changes occur, but it's not noticeable. For instance, if I have a pot that is tightly covered without any airspace, all right, for vapor to come out, and there's water in that pot, I will heat that pot to a point where the water gets to the boiling point. What's the boiling point of water? Who can remind me? 100 degrees Celsius. Good. When the water in that pot or in that beaker, let's work with a beaker that is well covered with a lid. When the water inside when the molecules of that water gain kinetic energy and approach 100 degrees Celsius, you find out that some molecules will escape and get to the cover. And when it gets there, what will happen is condensation will take place. And when condensation takes place, it will fall back again. And again, more molecules will gain energy and change towards vapor. Condensation will keep taking place. So that kind of system will get to a point, or it will get to a point whereby the amount of vapor that is leaving the water surface will be equal to the amount of water droplet that is coming back to the system. That kind of a system is what we know as what? A dynamic equilibrium. Because in the end, there is no net change. Okay? When equilibrium takes place in a chemical system, we call it a chemical equilibrium. The next thing I want us to look at today is the properties of a system that exists in chemical equilibrium. How do we determine, if you are given a system, for instance, how do you determine if that particular system is in chemical equilibrium? There are some things to look out for. In your JAM questions, for instance, if you see a particular question they're asking you, is this system in chemical equilibrium? There are some things, there are some conditions that must be met before we can draw a conclusion that that system is in chemical equilibrium. The first condition is that it can only be achieved in a what? Closed system. Closed system. Equilibrium you cannot have equilibrium in an open system. You have a system where there is an outlet. You know, when we prepare our laboratory apparatus and we're synthesizing a particular chemical substance, you find out that if there is an escape tube that is carrying the product away and the products are going off to be condensed, then equilibrium cannot be achieved because the products are being what? Reduced. So it must be in a closed system, a system where, if you recall vividly, you know that there are three, you can recall that there are three types of system. The first type of system is an open system. An open system is one in which there is what? Escape of product or reactants. Do you understand? That kind of system, an open system. Like you have a cooking pot and the pot is open. What happens? Steam will keep going on. So that system is an open system. Then we have what is called a closed system. A closed system, there is no loss in matter. Please take note. An open system, there is loss in matter. In a closed system, there is no loss in matter. Rather, there can be loss of what? Energy, or gain of energy. While in an isolated system, there is neither loss of what? Matter or what? Energy. Equilibrium can take place is what? In a closed system. There can be supply of pressure, supply of temperature, but matter, the amount of the product of the reactants should be constant, should be maintained. The next one is it is dynamic in nature. That is, it proceeds, it moves, it's not static, like the equilibrium that is achieved on a seesaw. The next condition we have that it can be approved from the point of view of what? A forward or what? A backward reaction. We have a simple reaction of this nature. We have A plus B giving us what? C plus what? B. A plus B producing what? C plus D is known as what? The forward reaction. While when C reacts to D again, C reacts to D again to give us what? A plus B. This is what we call what? The backward reaction. So this is the forward, and this is what? Backward reaction. The next point is that the concentration of chemical species is what? Constant. The concentration of chemical species is constant. In dynamic equilibrium, one thing we will find out in this kind of system is that the amount of AB will always remain constant, even though there is a loss, there is reaction, and AB is being converted to CD, yet CD is converted back to what? AB. So the amount of AB, if I have 2 and I remove 1 from 2, what will I be left with? I have to remove 1 from 2. Then I add 1 again. And I remove 1 and add 1. And add 1, then remove 1 and remove 1 again. What will I be left with? Okay, that kind of a system, there is what? No net change in the amount of the what? Product or reactant. A catalyst can only alter the time taken to reach equilibrium. A catalyst does not tell us whether the equilibrium will favor the forward or backward reaction. It doesn't determine equilibrium. It doesn't tell us if a system is in equilibrium or not. But it can speed up the rate at which what? Equilibrium is what? Attained in a system. The next thing we'll look at today is what we call a reversible reaction. This kind of a reaction is one that proceeds in both directions, the forward direction and what? The backward direction. That kind of reaction. The forward direction is indicated with the arrow that is pointing forward. Is like a half R. And the backward reaction is indicated with what? An arrow that is what? Pointing backwards. And lastly we said that a reversible reaction is in dynamic equilibrium if both forward and backward reaction occurs at the same rate, leading to no net change in reaction and product. The only changes that occur, the changes that take place are changes we know as what? Micro changes, micro reactions. They take place within the chemical system, but there are no observable change. There are no observable change in that system. Although changes occur, but those changes are not noticeable because as the product are formed, the products are used up to produce what? The reactant, and the reactant are used to produce what? The product. So you observe that the concentration of the reactant and the product remain the same in a chemical system that is in dynamic equilibrium.